Our reality might be far stranger than it appears. We are about to venture beyond the familiar three dimensions of space into an entirely different kind of realm, the hidden dimensions of thought. This is the startling idea that consciousness and the cosmos are deeply intertwined, a concept so wild it feels like the ultimate science fiction movie, except it might be true. By the end of this journey, you will see your own mind and the universe in a completely new light. We will uncover whether your thoughts are truly your own and if the cosmos itself could be conscious. What single idea about reality are you most ready to question your thoughts might not be happening inside your head? This is the startling claim of the holographic principle, a theory that reimagines the very fabric of our reality. It proposes that our seemingly solid, three-dimensional universe, along with everything in it, is actually a magnificent illusion. According to this idea, all the information that makes up our world, from distant galaxies to your most private memories, is encoded on a distant, two-dimensional surface at the edge of everything we can know. It is like a cosmic credit card hologram. That shimmering, three-dimensional eagle you see on your card is not really there. It is a projection from a flat, patterned surface. In the same way, the richness of your inner world, the feeling of depth and space within your own mind, could be a breathtakingly complex projection. This theory did not come from nowhere. It emerged from the profound mysteries of black holes. Physicists discovered that all the information about what falls into a black hole might be preserved on its two-dimensional boundary, the event horizon. If this is true for the most extreme objects in the cosmos, why not for the entire universe? Why not for the theater of your own consciousness, the screen where your thoughts and feelings play out? This leads to a truly dizzying possibility. The vivid internal movie of your life with all its colors, sounds, and emotions might not be generated locally. It could be a holographic show projected from the farthest edge of space, a cosmic illusion so perfect we are completely immersed in it. But this cosmic projection is not the only challenge to our sense of self. There is an even stranger possibility lurking in the void. The empty space around us is not truly empty. It is a seething sea of quantum fluctuations, where particles and energy pop into and out of existence in a random, chaotic dance. Given enough time, the statistics of this chaos suggest something almost unthinkable could occur. A fully formed, self-aware brain could spontaneously assemble from this quantum noise. This is the Boltzmann brain paradox. It would not be born, it would not grow, it would simply flash into being, complete with a lifetime of entirely fabricated memories, convinced of a reality that never actually happened. It would believe it had a childhood, it would recall the taste of its favorite food, and it would feel the warmth of a sun that never shone upon it. All of its thoughts, its entire conscious experience, would be an impeccable, instantaneous illusion. This leads to a deeply unsettling philosophical question. If such a phantom mind is statistically possible, however improbable, how can any of us be certain we are not one? Your most cherished memory, the foundational story of your life, could be nothing more than a random data point generated by a transient fluctuation in the cosmic vacuum. This is not just a thought experiment, it is a serious problem for modern cosmology. Some physicists argue that if our standard model of the universe makes a Boltzmann brain more likely to exist than a real, biological brain like yours, then that model must be fundamentally flawed. The debate forces us to confront the very nature of our consciousness. We trust our memories to ground us in reality, but what if that trust is built on a foundation of quantum sand? The reliability of thought itself is called into question, leaving us to wonder if we are stable beings in a vast cosmos, or just fleeting patterns in an endless, mindless chaos. Yet, even if our consciousness is not a phantom, where exactly does it live? Deep within the delicate architecture of your brain are structures far smaller than neurons, tiny scaffolds of protein called microtubules. According to the controversial OR theory proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, these minuscule structures could be the true seat of the soul. They propose that consciousness is not a simple byproduct of neural firing, the brain's classical computation. Instead, they argue it arises from quantum computations happening inside these very microtubules. Imagine these tiny tubes as the universe's most sophisticated quantum computers, where vibrations at the subatomic level perform calculations. The theory suggests that when these quantum vibrations reach a certain threshold, they collapse or reduce in a specific way orchestrated by the brain's biology. It is this objective reduction event that gives rise to a moment of conscious experience, a single frame in the movie of your mind. This is not just random noise, it is a fundamental process that could produce thoughts which are non-computable, meaning no ordinary computer, no matter how powerful, could ever replicate them. This is where the theory connects to the cosmos itself. Penrose believes these collapses are tied to the very fabric of spacetime, to its underlying geometry. Each flicker of awareness might be a microscopic event in the universe's structure. The criticism from mainstream neuroscience is fierce. Many argue the brain is too warm, too wet, and too chaotic for delicate quantum states to survive long enough to have any meaningful effect. They see consciousness as an emergent property of the brain's complex neural network, not its quantum vibrations, yet the idea remains profoundly intriguing. It paints a picture of our inner world not as a simple machine, but as a symphony of quantum vibrations, intimately connected to the fundamental geometry of the cosmos. Your every thought could be a ripple in the deep structure of reality. The idea that your thoughts are quantum symphonies is profound, but what if they are something even more extraordinary, lines of code in a cosmic computer? The simulation hypothesis argues that our entire universe and the consciousness within it is not base reality but an artificial construct, an immensely sophisticated digital simulation created by a far more advanced civilization. This is not just a plot from a science fiction movie, it is a serious philosophical argument championed by thinkers like Nick Bostrom. He presents a compelling trilemma, three stark possibilities, and at least one of them must be true. First, almost every civilization like ours goes extinct before it develops the technology to create realistic simulations. Second, advanced civilizations have no interest in running simulations of their own evolutionary past. Or third, we are almost certainly living in a simulation right now. If a civilization could survive and chose to run even a few simulations, the number of simulated minds would vastly outnumber the one original set of real minds. Statistically, you are more likely to be one of the countless simulated beings than a single organic original. This logic forces a radical shift in perspective. The hidden dimension here is not spatial, it is computational. Your stream of consciousness, your deepest sense of self, could be a carefully rendered data stream in a universe-sized processor. Everyday anomalies like déjà vu, that eerie feeling you have lived a moment before, could be explained as minor processing glitches or memory leaks in the system. Moments of bizarre coincidence or synchronicity might be the equivalent of background processes briefly becoming visible. Even the strange, probabilistic rules of quantum mechanics, where particles exist in multiple states until observed, fit neatly into this model, acting like a resource-saving rendering technique. The simulation only calculates the precise details of a scene when a conscious observer, a user, is looking at it. Of course, there are powerful counter-arguments. Some say the sheer computational power required to simulate every particle in a universe is physically impossible, even for an advanced civilization. Others argue that the messy, emotional, and deeply subjective nature of human consciousness feels too rich, too authentic to be mere code. Yet the simulation hypothesis retains its grip because it strikes at the core of our existence. It makes you question the very nature of your free will. Are your choices truly your own, or are they the predetermined output of an algorithm written long ago? Your life, with all its struggles and joys, could be a story being run on a server in a reality beyond our own, a thought that forever alters what it means to be real. A rock, a star, or a single electron might possess a tiny spark of inner life. This is the radical premise of panpsychism, an ancient idea experiencing a dramatic revival in modern science. It proposes that consciousness is not something that magically emerges from complex arrangements of matter, like the human brain. Instead, it suggests that consciousness is a fundamental property of the universe, as basic as mass or electrical charge. Just as an electron has a charge and a mass by its very nature, it might also have some primitive, raw form of experience, a faint whisper of feeling. We are not talking about a rock thinking philosophical thoughts. This is about a foundational layer of reality, a dimension of proto-consciousness that permeates everything. In this view, the cosmos is not a dead mechanical void. It is a vast, interconnected field of feeling, a universe that is in some deep sense awake. Modern thinkers are finding surprising connections between this ancient philosophy and cutting-edge physics. Some interpretations of quantum mechanics, with its strange observer-dependent effects, seem to hint at a universe where mind and matter are not so easily separated. Integrated Information Theory, or IIT, provides a mathematical framework for this. It attempts to measure consciousness by how much a system can integrate information into a unified whole. A human brain, with its trillions of connections, has a very high degree of integrated information, resulting in our rich conscious experience. But even a much simpler system, like a photodetector with just 2 possible states, could have a tiny amount, a minuscule glimmer of what it is like to be that device. This leads to a breathtaking vision of reality, where everything from the network of neurons in your head to the intricate structure of a galaxy is sitting on a vast spectrum of consciousness. Your own mind, then, is not an isolated miracle. It is a concentrated, highly complex gathering of these universal sparks, a whirlpool of awareness formed from a sea of mind. The cosmos itself could be a single, unimaginably vast thinking entity, and we are fleeting thoughts within its grand, eternal mind. Every choice you make shatters reality into a million pieces. This is the breathtaking promise of the many worlds interpretation, a theory that transforms the strange probabilities of quantum mechanics into a literal multiverse of branching timelines. Physicist Hugh Everett proposed that the universe does not choose a single outcome when a quantum event occurs. Instead, it chooses all of them. Every possible outcome blossoms into its own fully realized reality, splitting the cosmos again and again in an endless fractal of existence. The dimension here is one of pure possibility, a sprawling tree of alternate realities where every fork in the road is taken. Think of the last small decision you made, whether to turn left or right on your walk. In one universe, you turned left and saw a beautiful sunset. In the branch created the instant you decided, another version of you turned right and found a lost dog. Both events are equally real, both lives unfolding in parallel. This applies not just to your actions, but to the very thoughts in your mind. Every internal debate, every fleeting idea you dismiss, every path not taken in your imagination, creates a new universe where that thought became your reality. There is a version of you who pursued that crazy dream you were too afraid to follow. Another you held onto a relationship you let go. An infinite number of you exist, each with a slightly or vastly different stream of consciousness, each living a life built from the alternative thoughts you once had. This means your mind is not a single linear narrative. It is the trunk of a tree with infinite branches, a central point from which countless other versions of your awareness diverge forever. The you reading this now is just one thread in a tapestry of parallel minds, each convinced their reality is the only one. The implications are overwhelming. Every regret is soothed by the knowledge that in another world it is a triumph. every moment of pride is humbled by the existence of a world where you failed. The burden of choice is lifted, but so is the uniqueness of your journey. You are both everything and nothing special, one iteration in an infinite chorus of selves. The cosmos becomes a living library of every story that could ever be written, and your consciousness is simply reading one page at a time. Your own internal voice, the constant companion narrating your life, might be a historical novelty. Julian Jaynes, a psychologist from Princeton, put forward a theory so radical it seems to defy common sense, the idea that human consciousness as we know it is only about 3,000 years old. Before that pivotal era, he argued, people did not possess a unified self, an inner space where they deliberated and made choices. Instead, the human mind was bicameral, meaning it was a two-chambered system. One hemisphere of the brain, often the right, would generate a command or an intuitive prompt, perhaps during a moment of stress or indecision. The other hemisphere, usually the left, would perceive this internal signal not as its own thought, but as the audible voice of a god, a king, or an ancestral spirit issuing a direct order. There was no introspection, no sense of an I making a decision. A person simply heard a voice and obeyed. Jaynes scoured ancient texts for evidence, and he found it in some of humanity's oldest stories. In the Iliad, the epic poem of the Trojan War, heroes like Achilles and Hector are never described as pondering their options. They do not have internal monologues filled with doubt or reason. Instead, they consistently report hearing the voices of gods telling them exactly what to do. Athena pulls Achilles by the hair and tells him to stop his quarrel. A god whispers a battle plan directly into a warrior's ear. These were not metaphors to the people of that time, Jaynes argues. They were literal descriptions of a different kind of mental experience. The archaeological record seems to support this. Jaynes points to the proliferation of idols and oracles right up until this period. People needed constant external validation, a physical statue to look upon, because the guiding voice was perceived as coming from outside the self. So what happened to collapse the bicameral mind? Jaynes proposes that a series of colossal societal upheavals around the second millennium BC, including natural disasters, wars, and mass migrations, created situations so complex and novel that the simple voice of the god was no longer sufficient. The system broke down under the pressure. Metaphor and language evolved, allowing people to model the world and their own potential actions within it internally. This created an analog space, a mental workspace where we could simulate outcomes and narrate our lives. The voice of the god was gradually internalized, becoming what we now recognize as our own conscious inner speech. This implies a hidden dimension to thought itself, not in space but in deep time. The very fabric of your subjective experience, your feeling of being a self in charge of your actions, could be a cultural and neurological adaptation, a new layer of reality that emerged relatively recently in cosmic terms. It forces a profound question: is your inner narrator the true essence of you, or is it just the latest operating system for the human brain, a piece of mental software that was installed by the pressures of a collapsing Bronze Age world? Yet that inner narrator, that recent arrival in human history, needs a stage on which to perform. Inside your mind there is a theater. This is the central metaphor of the global workspace theory, a powerful model from cognitive science that maps a functional dimension to your thoughts. Picture a vast, dark theater. The stage is filled with actors, sets, and crews, all working furiously in the shadows. These are your brain's unconscious specialized processors, each an expert in its own domain. One handles the complex geometry of catching a ball, another deciphers the subtle emotional tone in a loved one's voice, and yet another manages your sense of balance, all without you ever being aware of the intricate calculations happening backstage. Your conscious mind is not the entire production, it is a single, bright spotlight. This spotlight swings across the stage, and whatever it illuminates is suddenly brought into the global workspace. That information, that specific thought or sensation, is now broadcast to the entire theater, making it available to all the other unconscious processors at once. The feeling of a sudden itch on your ankle is processed backstage for a moment, but the instant the spotlight swings onto it, it becomes a conscious sensation. Now the processor for planning movement knows to scratch it. The memory system might recall the last time you were in this grassy park, and the language center stands ready for you to say, "Something is biting me." Before the spotlight hit it, the itch was just local data. The moment it was broadcast globally, it became your conscious reality. This explains why your conscious thoughts feel so limited, why you can only truly hold one or two complex ideas in your mind at a time. The spotlight can only illuminate one part of the stage at any given moment. The vast, rich, and incredibly complex work of your mind, from recognizing a face to feeling a gut instinct, happens in the darkness outside the beam of your awareness. Your stream of consciousness is not the whole show. It is just the lead actor currently standing in the light, being watched by an audience of hidden experts. This functional architecture solves a critical problem for the brain. It creates a central information exchange, allowing all these separate, unconscious modules to share their findings and coordinate your behavior. A distant sound processed backstage might not be important until the spotlight suddenly grabs it, broadcasting a potential danger to your entire system and making you jump. Your conscious mind is the unifier, the director that takes all these disparate pieces of information and weaves them into a single, coherent narrative of your experience. So the next time a forgotten name suddenly pops into your head, it is not magic. It is the result of unconscious processors working in the dark, finally finding the answer and pushing it onto the stage, directly into the bright, waiting beam of your conscious awareness. But that spotlight of consciousness, the one that illuminates your personal stage, might be shining from a universal source. What if the feeling of being aware could be measured with a number? This is the provocative claim of integrated information theory, or IIT, developed by neuroscientist Giulio Tononi. It proposes that consciousness is not a magical byproduct but a specific physical phenomenon, the amount of integrated information a system can generate. Think of it this way: a photodiode, a simple light sensor, has just two states, on or off. It processes a tiny bit of information, but it is not integrated. Its state of on does not really affect its state of off in a meaningful way. Its phi, the mathematical symbol for this quantity, is nearly zero. Now consider the human brain. It is not just a collection of on-off switches. It is an incredibly dense network of billions of neurons, each one influencing countless others in a complex, unified dance. A single memory can alter a decision, which can change an emotion, which can trigger a physical action. Because all these parts are so deeply interconnected, working together as a single, irreducible whole, the system generates a massive amount of integrated information. According to IIT, this high phi value is what produces our rich, vivid conscious experience. The theory makes a truly startling prediction. Consciousness is not exclusive to biological brains. Any system that has a high enough degree of phi could, in principle, possess some level of awareness. A sophisticated computer circuit, if its connections were complex and integrated enough, might not just simulate thinking, it might have a genuine inner life, however simple or alien it might seem to us. This logic leads to a breathtaking, and some would say troubling, conclusion. The entire universe is a system of unimaginably vast interconnection, from the quantum entanglement of particles to the gravitational dance of galaxies. If IIT is correct, then the cosmos itself, as a single, unified system, could have a phi value approaching infinity. It might possess a cosmic consciousness, a vast, timeless awareness of which our own minds are merely small, temporary fragments. We could be thoughts within a single, universal mind. Critics, however, point to a major problem they call consciousness inflation. If even a simple computer chip has a tiny amount of phi, does it have a tiny spark of feeling? Does a thermostat with its feedback loop have a minuscule degree of consciousness? This seems to many like an absurd overreach, attributing inner life to far too many things. Yet the power of IIT lies in its bold, mathematical approach. It does not rely on mysterious substances or spiritual ideas. It attempts to quantify the ghost in the machine, to find the precise structural difference between a conscious being and an unconscious object. It forces us to ask whether our own sense of self is just a reading on a cosmic scale, a specific measurement of interconnected complexity in a universe that might be far more awake than we ever dared to believe. Our individual streams of thought might be merging into a planetary river of consciousness. This is the visionary concept of the noosphere, a term coined by the philosopher and paleontologist Pierre Teilhard de Chardin. He envisioned a profound evolution of our planet, a series of enveloping layers. First came the geosphere, the world of rock and mineral. Then life emerged, creating the biosphere, a thin, vibrant skin of living things. Now, with the arrival of humanity and its capacity for reflexive thought, a new layer is being born, the noosphere, a thinking envelope of shared ideas and collective consciousness that wraps around the entire globe. Teilhard saw this not as a metaphor, but as a real, biological and psychological fact, the next logical step in Earth's evolution. It is a global mind, a hidden dimension of thought where our individual minds are like neurons in a single planetary brain. You can see a primitive, technological version of this emerging all around us. The internet, with its instantaneous flow of information and connection, acts as a crude, early nervous system for this planetary mind. Every search query you type, every message you send, every idea you share online is like a single synaptic firing, contributing to the thoughts of this larger entity. Your personal curiosity about the world, your moments of insight or creativity, do not exist in a vacuum. They are pulses of energy sent into this collective field, influencing its overall state and direction. This suggests a breathtaking purpose for humanity. We are not just isolated beings struggling for survival. We are the cells of a nascent superorganism, a global brain slowly waking up to its own existence. Our wars and conflicts could be seen as growing pains, the chaotic firing of a nervous system that has not yet fully integrated. Our moments of global cooperation and shared wonder, like watching a spacecraft land on Mars, are flashes of coordinated thought, moments when the planetary mind focuses its attention. The noosphere implies that the hidden dimension of thought is not inside your head or at the edge of the universe, but all around you, in the invisible network of human connection and shared understanding that we are all building together, one thought at a time. There is a library that contains every thought you have ever had. This is the ancient and enduring concept of the Akashic Records, a theoretical dimension said to hold the complete history of every human soul. Imagine a cosmic internet, an ethereal and infinite archive where every event, every whispered word, every surge of emotion, and every silent intention is permanently recorded. This is not a physical place made of paper and stone, but a non-physical realm of pure information, a hidden dimension of knowledge that underlies our own. The term itself comes from theosophy, a spiritual philosophy that emerged in the 19th century, drawing from even older Eastern traditions of a universal life force. Here, the Akashic Records are seen as the book of life, a complete chronicle of the past, present, and even potential futures, accessible only through deep spiritual or intuitive states. It is as if the universe itself is constantly writing a biography of existence, and this library is its only copy. Some modern thinkers have tried to find a scientific footing for this mystical idea. They point to the strange, interconnected nature of quantum physics, where particles can be entangled across vast distances, instantly influencing one another. Could this quantum weave be the physical substrate for a field of shared information, a kind of universal memory. Others point to biologist Rupert Sheldrake's controversial theory of morphic fields, which proposes that natural systems, including minds, inherit a collective memory from all that has come before. A rat in a lab in London might learn a maze faster because rats in Tokyo have already learned it, their accumulated experience somehow resonating through a non-physical field. In this light, the Akashic Records could be the ultimate morphic field, the collective memory of all humanity. Your moments of sudden inspiration, a brilliant idea that seems to come from nowhere, might be your consciousness briefly tapping into this vast database. That eerie feeling of knowing something you were never taught could be a fleeting connection to this cosmic library. It suggests that no thought is ever truly lost and that your inner world is forever interwoven with the timeless tapestry of all human experience. Your own memories might be shared by millions, yet completely wrong. This is the bizarre reality of the Mandela Effect, a phenomenon where countless people independently recall the same specific details about the past, only to discover their memories are incorrect. It is named for the widespread, vivid recollection that Nelson Mandela died in prison during the 1980s, when in fact he was released and became president of South Africa. This is not simple forgetfulness, it is a collective misremembering on a massive scale, and it has become a modern clue pointing toward the hidden dimensions of thought. Take the classic children's book series, The Berenstain Bears. A vast number of people would swear on their lives that the name was always spelled Berenstein. They recall the playful, rhyming sound of Berenstain Bears, a memory often tied to their own childhoods. Yet every piece of official evidence, from book covers to copyright records, confirms it has always been Berenstain with an A. This small, stubborn letter has sparked enormous controversy. How could so many minds independently fabricate the same alternate reality? One compelling theory suggests this could be a literal glimpse into a parallel universe. In the framework of the many worlds interpretation, perhaps our collective consciousness is not entirely isolated. Maybe, for a fleeting moment, a large group of people briefly accessed or tuned into a reality where the spelling truly was Berenstain, and that memory bled into our own timeline. Another explanation ties directly to the simulation hypothesis. If our universe is a constructed reality, these shared false memories could be the equivalent of software glitches or patches. An early version of the simulation might have featured the Berenstain spelling, and when the developers updated the code to Berenstain, not every user's memory cache was perfectly cleared, leaving residual data that some can still recall. Other famous examples only deepen the mystery. Many clearly remember the Monopoly Man, the mascot from the board game, wearing a monocle he never has. People vividly recall a children's movie from the 1990s called Shazam, starring the comedian Sinbad as a genie, a film that simply does not exist in our historical record. The collective mind seems to be insisting on events and details that have no physical evidence to support them. This forces a radical question about the nature of reality itself. Is our past a fixed, objective record, or is it something more fluid, shaped and reshaped by the collective focus of our consciousness? The Mandela Effect reveals that memory is not a perfect video recording. It is a constructive and sometimes collaborative process. When millions of people build the same false memory, it suggests our thoughts are not locked inside our individual skulls, but are part of a larger, interconnected field, a noosphere where information can be shared or even corrupted on a planetary scale. Your most certain childhood memory might be a ghost from another dimension or a glitch in the cosmic code, proving that the fabric of our shared reality is far more malleable than we ever believed. A new idea suggests the very laws of nature are not fixed, but are instead solidified habits. This is the radical theory of morphic resonance proposed by biologist Rupert Sheldrake. It challenges the foundation of modern science by proposing that the way a thing is formed is guided by an invisible field of collective memory. A crystal does not form in a specific shape just because of blind physical laws. According to Sheldrake, it forms that way because every crystal of that type that has ever existed before has left an imprint on a non-physical field, a morphic field that guides its successors. The more often a pattern is repeated, the stronger and more habitual this field becomes, making it easier for future systems to fall into the same form. This creates a hidden dimension of cosmic habits, a realm of influence that connects all similar things across both space and time. The most striking evidence for this comes from animal behavior. In a classic series of experiments, rats were taught to run a complex maze. As the first generation of rats slowly learned the route, subsequent generations, even when they were completely isolated and had no physical contact with the earlier rats, seemed to learn the maze progressively faster. The controversial interpretation is that the knowledge gained by the first rats somehow became part of a collective rat mind, a morphic field that made the task instinctively easier for rats everywhere. This was not a transfer of genes, but a transfer of learning through a field of resonance. Apply this to your own mind, and the implications are staggering. Your sudden intuition, that gut feeling you cannot logically explain, might be you tapping into this vast reservoir of human experience. A solution to a problem might pop into your head not because you alone figured it out, but because you resonated with the collective breakthroughs of thousands of other minds who have struggled with similar challenges before you. It offers a scientific, albeit controversial, framework for the ancient concept of a collective unconscious, a shared well of archetypes and knowledge that all humanity can draw upon. The scientific establishment largely rejects morphic resonance. Critics argue the rat experiments are flawed and that the results can be explained by selective breeding or improved experimental techniques. They demand repeatable, controlled evidence that this field actually exists, something that has been elusive. The theory remains on the fringes because it proposes a fundamental force that science cannot yet measure with its current tools. Yet its appeal endures because it addresses the mysteries of life that conventional biology often ignores. It paints a picture of a living, learning universe where our thoughts and actions contribute to a growing field of collective memory, subtly shaping the reality of everything that comes after. The empty void of space holds a secret energy, a boundless ocean of information waiting to be read. This is the zero-point field, the fundamental ground state of the universe. Even at a temperature of absolute zero, where all classical motion is supposed to cease, the quantum world is a seething, bubbling cauldron of activity. Virtual particles wink in and out of existence in a relentless, chaotic dance, filling the vacuum with an infinite sea of energy and potential. This field is not empty, it is a plenum, a fullness of unimaginable activity that underlies all of reality. Some theorists propose a breathtaking connection, that this fundamental field is not just the source of matter and energy, but the very wellspring of consciousness itself. In this view, your thoughts are not merely chemical reactions confined to your skull. They are intricate patterns of information, ripples and waveforms drawn from this cosmic sea. Your brain, with its staggering neural network, might not be a generator of consciousness, but a supremely sophisticated receiver. It is like a radio, exquisitely tuned to pluck specific frequencies of information from the infinite static of the zero-point field. The music you hear on a radio does not originate within the radio's components. The device simply translates invisible electromagnetic waves from the air into a form you can perceive. In the same way, the symphony of your inner world, your memories, your ideas, your sense of self, might be a translation of information plucked from this universal field. This explains the mysterious nature of intuition, those flashes of insight that seem to come from nowhere. You might be momentarily tuning into a frequency of information that exists all around you, a solution encoded in the field itself. It also reframes the very fabric of reality, suggesting that the cosmos is fundamentally a realm of mind, a field of potential thought, and we are localized points where that potential becomes actual experience. The static between stations on a radio dial is not true silence, it is a cacophony of every broadcast happening at once. Your conscious mind, then, is the act of tuning the dial, of focusing on one coherent signal from the infinite noise of cosmic possibility. A powerful psychoactive compound may have been the unexpected key to our own minds. This is the provocative stoned ape theory proposed by ethnobotanist Terence McKenna. He suggested that the evolution of human consciousness was not a slow, gradual process, but a sudden, dramatic leap triggered by a dietary change. As our ancient hominid ancestors, like Homo erectus, moved from the dense forests to the open grasslands of Africa, they would have followed the herds of grazing animals. And where these animals grazed, their dung would have been a fertile ground for a specific type of psilocybin mushroom. McKenna proposed that when our ancestors consumed these mushrooms, even in small doses, it had several immediate and profound effects. First, it supposedly enhanced their visual acuity. In a vast, open savanna, spotting predators or finding food from a distance was a matter of life and death. A slight sharpening of the senses could offer a massive survival advantage. At slightly higher doses, the theory goes, the mushrooms would have acted as a powerful aphrodisiac, increasing sexual arousal and communal bonding. This would have led to larger, more cohesive tribes and a population boom. But the most radical part of the theory concerns language and self-awareness. McKenna argued that in the psychedelic state, the brain's pattern recognition systems go into overdrive. The world becomes a tapestry of interconnected symbols and meanings. Early humans grappling with these novel, internally generated visions and the breakdown of their ordinary perception were forced to invent new sounds, new grunts and gestures to communicate their unprecedented experiences to each other. The need to describe the indescribable may have been the very pressure that catalyzed the birth of complex language. With language came the ability to model the world internally, to tell stories, and to reflect upon oneself. The voice of the god, the command hallucination of the bicameral mind, could have first emerged from these potent, plant-induced states. Religion itself, the feeling of a vast, intelligent other, might have its roots in the direct, mystical experience provided by these fungi. This theory presents a deeply challenging idea that a pharmacological key, a simple molecule, unlocked a new dimension of thought for early hominids. It pushes back against the idea of consciousness as a purely internal, self-generated phenomenon, suggesting instead that our inner world was sparked by an external, chemical key found in the natural environment. It frames our highest faculties, language and self-reflection, not as a slow, logical ascent, but as a sudden, psychedelic explosion, a cognitive threshold crossed with the help of a humble mushroom. Your brain might be the most powerful quantum computer in the known universe. This idea pushes beyond the model of neurons as simple on-off switches, proposing that the very heart of our cognition operates on the bizarre principles of quantum mechanics. In the quantum realm, a particle can exist in multiple states at once, a phenomenon called superposition. It can also become spookily connected to another particle, instantly influencing it across any distance, a property known as entanglement. If these processes are at work inside your head, it could explain the mind's most elusive qualities. Consider the lightning speed of insight. That moment a solution to a complex problem pops into your awareness fully formed. A classical computer would need to check every possibility one by one, a laboriously slow process, but a quantum computer could explore all possible solutions simultaneously through superposition, collapsing into the correct answer in an instant. Your own flashes of genius might work the same way. Your creative leaps where you connect two seemingly unrelated ideas could be a form of mental entanglement where distant concepts in your mind become linked in a novel and meaningful way. This even touches on the mystery of free will. In a purely classical, deterministic brain, every thought would be the inevitable result of prior electrical states, leaving no room for genuine choice. But if quantum indeterminacy plays a role, if the collapse of a superposition inside your neurons is not perfectly predictable, then a window opens for will to influence the outcome. Your decisions would not be mere calculations, they could be genuine acts of creation arising from the quantum fog. The physicist Roger Penrose and anesthesiologist Stuart Hameroff placed this quantum action deep within the brain's neurons in tiny structures called microtubules. These protein scaffolds, they argue, are small enough and organized enough to protect fragile quantum states. They propose that these microtubules perform quantum computations and that the collapse of these quantum waves is what produces a moment of conscious awareness. This would place your stream of thought directly in the realm of quantum weirdness, making your consciousness a tangible part of physics itself. Of course, this remains fiercely debated. Critics point out that the brain is warm, wet, and noisy, an environment where most physicists believe delicate quantum states would almost instantly decohere, falling apart into ordinary randomness. Yet, the theory persists because it addresses the hard problem of consciousness head-on. It suggests that the non-local, unpredictable, and profoundly creative nature of thought might have a direct counterpart in the non-local, probabilistic, and deeply strange foundation of the universe. Your mind does not end at the boundaries of your skin. This is the core of the extended mind hypothesis, a philosophical idea that shatters the illusion of the skull as a sealed vault for thought. It proposes that the tools we use, the notes we write, and the devices we rely on are not just external aids, they are literal parts of our cognitive system. Our consciousness leaks out into the world, creating a hidden dimension of thought that exists in the dynamic interplay between our brains and our environment. To understand this, consider the famous thought experiment of Otto and Inga. Both decide to visit a museum. Inga has a healthy biological memory. She thinks for a moment, recalls the museum's address, and walks there. Her memory process is entirely internal. Otto, however, has early Alzheimer's disease and struggles with his internal memory. To cope, he constantly uses a notebook, jotting down important information he knows he will need. When Otto wants to go to the museum, he consults his notebook, finds the address written inside, and walks there. The philosopher's question is this: is Otto's notebook fundamentally different from Inga's biological memory? Both stored the information reliably, both retrieved it when needed to guide their action. The argument is that the notebook is playing the exact same functional role for Otto that his hippocampus plays for Inga. It is part of his memory system. The mind of Otto is not just in his head, it is a coupled system of brain plus notebook. This logic extends directly to our modern world. Your smartphone is not just a convenient tool you carry in your pocket. It is, in a very real sense, part of your extended mind. You do not memorize phone numbers anymore. Your phone's contact list holds that information for you, ready for instant retrieval. You use its calendar not as a reminder, but as your externalized prospective memory, the part of your mind that knows what you are doing next Thursday. The internet acts as your outsourced knowledge base, an always accessible extension of your own understanding. When you quickly search for a fact to settle a debate, that process is cognitively identical to racking your brain for a memory. The only difference is the location of the information store. This means the boundaries of yourself are far more fluid than you ever realized. Your thoughts are not all generated internally, they are completed in the world. The act of thinking often involves this loop. A question forms in your brain, you consult your phone, and the answer completes the thought, closing the cognitive circuit. Your mind is a network that weaves through the digital and physical environment, constantly reaching out and incorporating the world into its own functional architecture. The pen in your hand, the list on your refrigerator, the GPS in your car, these are not just objects. They are the very scaffolding of your consciousness, physical anchors for a mind that has always been larger than the brain alone. Your thoughts might be reaching back from the future to meet you in the present. Time itself could be a two-way street for consciousness, a dimension where the mind operates in both directions at once. This is the startling claim of time-symmetric theories, which propose that our linear experience of cause and effect is an illusion. Your brain may not just be a product of its past, it could also be subtly shaped by events that have not yet occurred. A series of controversial experiments seem to support this. In studies on presentiment, participants are shown a random series of images. Some are calm and serene, while others are violently shocking. Researchers measure subtle physiological signals like heart rate, skin conductance, and brain activity. The results are baffling. Consistently, a person's body begins to react to a shocking image a few seconds before it is even selected and displayed on the screen. It is as if their unconscious mind is peeking a moment into the future, preparing their system for the coming jolt. This is not about predicting the likely outcome of a situation. It is a physiological response to a specific, randomly chosen event that has not yet happened. Another line of research into precognition has yielded similar results. In one experiment, participants were asked to guess where a picture would later appear on a computer screen. The location of the picture was determined entirely at random after the person made their guess. Yet, across thousands of trials, participants correctly guessed the future location at a rate that defied pure chance. Their conscious guesses seemed to be influenced by information that, from our standard perspective, did not yet exist. These findings suggest that the flow of information into our minds is not a one-way stream from past to present. It might be more like a pond where ripples from both the past and the future converge to create the single moment we call now. Your decision in this instant could be influenced by a future consequence, a potential reward or punishment that your mind is somehow already aware of on an unconscious level. This radically reframes the nature of thought. A creative breakthrough does not just come from mulling over past knowledge. It might be your mind finally connecting with a solution that already exists in your future, a moment of insight traveling backwards to meet you. That gut feeling telling you to avoid a certain path could be a warning sent from a future disaster. If this is true, then your consciousness is not a tiny raft being pushed down the river of time. It is the river itself, existing all at once, with your present awareness merely a point of focus navigating its eternal flow. Our planet itself might be a single conscious being. This is the profound leap taken when we push James Lovelock's Gaia hypothesis beyond its original scope. Lovelock proposed that Earth's biosphere acts as a single, self-regulating entity, maintaining conditions suitable for life through complex feedback loops between the air, the oceans, and the land. But what if this planetary-scale homeostasis is not just a mechanical process? What if it is the behavior of a vast, slow, and distributed intelligence? Imagine a form of consciousness so immense and patient that its thoughts are the turning of seasons. Its memories are written in fossil layers, and its moods are the long, slow cycles of ice ages and warming periods. In this view, the intricate network of life is not just a system, it is a mind. The fungal mycelium weaving through the soil acts as planetary synapses, transmitting chemical signals. The global water cycle functions as its circulatory system, and the atmosphere is a shared lung. Human civilization, with our rapidly evolving technology and global communication networks, could then be seen as this being's newly evolved nervous system. Our thoughts, our internet, our collective projects are the first flickers of planetary self-awareness. Your own mental life, your worries, and your wonders are not isolated events. They are tiny, vibrant impulses in a global brain that is just beginning to wake up and think about itself. This adds a staggering cosmic scale to our existence. The ambition to understand the universe is not just a human quest. It is the Earth beginning to look up at the stars and wonder about its place in the cosmos. Our drive to connect and share information mirrors the planet's need to integrate its own knowledge. Yet this also comes with a deep responsibility. If we are part of a planetary mind, then ecological destruction is not just an environmental problem, it is a form of self-harm. Polluting the oceans is like poisoning our own blood. The loss of biodiversity is the erosion of planetary memory. We are not separate from Gaia, we are its growing consciousness, faced with the ultimate choice of protecting the body that sustains us or severing the very connections that allow it and us to think and to be. Yet the Earth's silent intelligence still leaves a deeper mystery untouched. Why does any of this feel like anything at all? This is the heart of the hard problem of consciousness, a philosophical challenge so profound it might reveal a fundamental gap in our entire understanding of reality. The philosopher David Chalmers drew a sharp line between what he called the easy problems of consciousness and the truly hard one. The easy problems are the ones neuroscience is busy solving. They involve explaining how the brain performs its functions, how do we integrate information from our senses, how do we focus our attention, how do we report our internal states. These are puzzles of mechanism, complex but ultimately solvable through enough research into the brain's wiring and chemistry. The hard problem is something else entirely. It asks why all this physical processing is accompanied by subjective inner experience. Why do electrical signals zipping between neurons create the deep, saturated red of a rose, the bittersweet ache of a forgotten memory, or the warmth of the sun on your skin? These private, qualitative feels are what philosophers call qualia, and their existence is the central mystery. You could know everything about the physical workings of a brain, every last detail of its structure and firing patterns, and still have no answer to why that brain has an inner world. This suggests a fundamental gap in our scientific story. Physics describes the mass and spin of particles. Biology describes the functions of organs, but nothing in these descriptions explains the leap from objective process to subjective awareness. The hard problem points to the possibility that consciousness is not something that emerges from complexity alone. It might be a fundamental feature of the cosmos, a basic property woven into the fabric of existence that we have not yet discovered. There could be a hidden dimension of reality, not of space, but of experience itself, where the inner light of consciousness resides. Your most personal feelings, the very essence of your being, might be rooted in this deeper layer of the universe, a dimension where the physical and the mental finally meet. The universe is not just a place where thinking happens, it is the thinking itself. This is the audacious claim at the heart of the cognitive theoretic model of the universe, or CTMU, a theory developed by Christopher Langan. It proposes that reality is not a collection of separate objects governed by blind physical laws, but a single, self-aware mind in a constant state of self-creation. In this view, the cosmos is a self-configuring, self-processing language, a living syntax that writes its own rules as it goes along. To grasp this, picture a cosmic computer of unimaginable scale. In an ordinary computer, you have a physical machine, the hardware, and the programs it runs, the software. The CTMU says the universe is both at once. The stars, the planets, the very space between them, this is the hardware. The laws of physics, the constants of nature, the patterns of evolution, this is the software. But here is the crucial twist: the universe is also the programmer. It is a closed loop of existence where the system designs and executes its own code in real time. This means your own consciousness is not a passive observer watching a pre-recorded cosmic film. You are an active, participatory element in this grand computation. Your thoughts, your observations, and your very act of questioning reality are not just happening within the universe. They are processes through which the universe thinks about and reconfirms its own existence. Every time you solve a problem, experience a moment of beauty, or simply decide to look at the stars, you are contributing a line of code to the ongoing program. The universe is using your mind as a focal point to know itself. This resolves the ancient paradox of how a mind can arise from seemingly dead matter, because in this model, matter was never truly dead to begin with. It was always the manifested thought of a universal mind, a mind in which we are all immersed and to which we all contribute. The CTMU presents a reality that is ultimately unified, conscious, and profoundly participatory, suggesting that your inner world is not a tiny refuge from a vast, uncaring cosmos, but the very medium through which the cosmos cares, learns, and evolves. A powerful chemical key might be hiding within your own brain. Dimethyltryptamine, or DMT, is one of the most potent psychedelic compounds known, and it is produced naturally in small amounts by the human body. This fact has led to a radical hypothesis that our brains manufacture this substance for a profound purpose. Dr. Rick Strassman, a clinical psychiatrist, conducted groundbreaking government-approved research in the 1990s, injecting volunteers with DMT and documenting their experiences. He called it the spirit molecule, proposing a startling theory. DMT might be released in massive waves at critical junctures of our lives, at birth, at the moment of death, and during intense spiritual or near-death experiences. In these pivotal moments, the brain may use this endogenous chemical to unlock a hidden channel of perception. The experiences reported by Dr. Strassman's volunteers were not just simple visual hallucinations. They consistently described being catapulted into what felt like entirely separate, coherent realities, dimensions teeming with intelligent, non-human entities. These beings often communicated with the volunteers, imparting complex information or performing intricate technological procedures on them. The encounters felt more real than everyday reality, leaving a lasting impression that they had journeyed to another place that was always there, just normally beyond our perceptual reach. This suggests that DMT does not just create fantasy, it might function as a neurochemical antenna, tuning the brain to receive frequencies of existence that are usually filtered out. Your brain, in its standard operating mode, processes a narrow slice of reality to help you navigate the physical world. But at the boundaries of life or in states of deep trance, a flood of DMT could dissolve that filter, allowing consciousness to perceive a far wider and more bizarre spectrum of the cosmos. The pineal gland, a tiny, light-sensitive structure deep in the center of the brain, has long been considered a potential seat of spiritual insight. Dr. Strassman theorized it could be the very organ that produces this visionary compound. If he is correct, then the most extraordinary journeys do not require a spacecraft. They are written into our very biology, a birthright waiting to be activated at the beginning and end of life. This paints a picture of consciousness not as a prisoner of the skull, but as a traveler with our own biochemistry providing the key to dimensions of thought and reality we are only beginning to comprehend. The cosmic web looks unnervingly familiar. Stretching across the voids of space, vast filaments of dark matter connect galaxies in a pattern that mirrors the neural networks inside your own brain. This is not a simple coincidence of shape. It is a hint at a deeper truth that the universe itself might be a kind of cosmic brain, a learning, evolving computational system on the grandest possible scale. In this model, the fundamental laws of physics are not static rules. They are the algorithms of this system. Gravity, electromagnetism, and the nuclear forces are the basic code that governs how information, in the form of energy and matter, flows through the cosmic network. A star is not just a ball of plasma, it is a processing unit fusing elements and releasing energy in a cosmic calculation. A galaxy is a dense cluster of computation, and the slender threads of dark matter that bind them are the synaptic connections carrying signals across the immense voids. This suggests that cosmic evolution, from the Big Bang to the formation of life, is not a random unfolding but a form of cosmic thought. A slow, deliberate process of a universe learning about its own structure and potential. Where does that leave you in this vast thinking cosmos? Your mind is not a separate miracle. It is a localized node in this network, a dense concentration of cosmic computation that has become self-aware. Your every thought, your every memory is a microcosm of the universal process, a small-scale version of the information integration happening across the galaxy clusters. You are not just living in the universe, you are a thought that the universe is having, a single point of focus in its own endless, unfolding cognition. You could meet your perfect physical double, and it would still lack the one thing that truly defines you. This is the unsettling core of the philosophical zombie argument, a thought experiment designed to challenge our most basic assumptions about the mind. A philosophical zombie is not the shambling, mindless creature of horror movies. It is, in every conceivable physical detail, an exact duplicate of a human being. Its brain has the same neural structures, its body has the same biochemical reactions, and it behaves exactly as you or I would. It would laugh at a joke, cry at a sad movie, and scream in pain if you pricked its finger with a needle. From the outside, you could never tell the difference, but on the inside, there is nothing. No inner light, no subjective experience, no feeling of what it is like to be that being. The red of a rose would trigger the correct verbal response, but there would be no experience of redness. The pain from the needle would cause a flinch and a shout, but there would be no actual feeling of hurt. The zombie is a perfect robotic imitation of a person, running on pure, unconscious autopilot. The power of this argument lies in its sheer conceivability. If you can coherently imagine such a being, then consciousness cannot be fully explained by physical processes alone. If everything physical were enough, then your physical double would necessarily have your conscious experience. The fact that we can imagine a scenario where it does not suggest a profound gap in our scientific story. The philosopher David Chalmers, who popularized this argument, uses it to highlight the hard problem of consciousness. It points directly to the mystery of qualia, those private, ineffable feelings that make up the texture of your existence. Your zombie twin would process the wavelength of red light, but it would never know the deep, saturated quality of the color itself. It would analyze the sound waves of a symphony, but it would never be moved by the bittersweet swell of the music. This implies that there is a hidden dimension to thought, a non-physical property that is added to the complex machinery of the brain. It is not something you can weigh or measure, yet it is the very essence of what it means to be you. This argument forces a stark choice. Either consciousness is a fundamental ingredient of reality, a kind of mental stuff that is as basic as space and time, or our own deep intuition about our inner lives is fundamentally mistaken. The P-zombie thought experiment does not prove that such beings exist, only that the idea is logically possible. And that possibility alone is enough to shake the foundations of a purely physical worldview. It suggests that your most intimate experiences, the very core of your being, might be rooted in a reality that transcends the world of atoms and energy. The zombie is a mirror that reflects back everything you are, except for the one thing that matters most, the silent, invisible witness watching from behind your own eyes. Your brain receives a constant, chaotic flood of separate signals. The color of an apple is processed in one region, its round shape in another, the smooth motion of your hand reaching for it in a third, and the crisp sound of the bite in yet another. So how do these fragmented data streams combine into the single, seamless experience of eating an apple? This is the binding problem, one of the most profound mysteries in neuroscience. There is no central processor in your head, no little person watching a screen, no single spot where it all comes together. Your unified reality is an illusion crafted from distributed chaos. The leading theory suggests that consciousness is an emergent property, a kind of magic trick performed by the entire brain working in concert. It is like the wetness of water. A single water molecule is not wet, but when trillions of them gather, the property of wetness emerges. In the same way, a single neuron firing does not create a thought, but the precise, synchronized firing of billions of them might give rise to the unified stream of your awareness. This synchronization could be the hidden organizational dimension, a temporal binding that weaves the separate threads of perception into a whole. Imagine an orchestra without a conductor. Each musician is a specialist playing their own part. The violins handle the melody, the cellos the harmony, and the percussion the rhythm. They do not need a conductor telling them what to do if they are all reading from the same score and listening to each other, synchronizing their timing perfectly. In that moment of perfect rhythm, the symphony emerges. Your brain might work the same way, binding the color, shape, and sound of the apple not in a place but in a moment of shared time. This means your conscious thought is not a thing located somewhere, but a dynamic process, a fleeting pattern of coordinated activity that constantly forms and dissolves. The binding problem reveals that the coherence of your world is not a given. It is a hard-won achievement of your nervous system. Every single moment of your life is a masterpiece of orchestration, created from a cacophony of separate parts, hinting at a hidden dimension of organization that transforms neural noise into the symphony of the self. The quantum world refuses to settle down until someone is watching. At its most fundamental level, a particle does not have a definite location or state. It exists as a blur of probabilities, a wave of potential spread across space. This wave function, as it is called, only collapses into a single, concrete reality when it is measured or observed. But what or who qualifies as an observer? This question leads to one of the most radical interpretations of quantum mechanics, championed by physicists like John von Neumann and Eugene Wigner. They argued that the instrument used to measure the particle is not enough. It is just another part of the quantum system. The final collapse requires something beyond the physical apparatus. It requires a conscious mind. In this view, consciousness is not a passive byproduct of the brain. It is the active force that crystallizes reality from a sea of possibility. Your act of looking, of being aware, is what forces the universe to make up its mind. To illustrate this dizzying idea, Eugene Wigner proposed a famous thought experiment. Imagine his friend is inside a sealed laboratory, about to perform a measurement on a quantum particle, like an atom that is in a superposition of both decayed and not decayed. Wigner himself is outside the door. From the friend's perspective inside the lab, he performs the measurement and gets a definite result: the atom has decayed. His consciousness has collapsed the wave function for his own reality. But for Wigner, standing outside, the entire laboratory, including his friend and the measuring device, is still part of a blurry quantum system. He must describe the entire scene as a superposition, a state where his friend has both seen the atom decay and has not seen it decay simultaneously. Only when Wigner opens the door and asks his friend what he saw does the entire superposition collapse into one consistent history. This experiment creates a paradox of conflicting realities. Whose observation counts? Is the universe split between Wigner's truth and his friend's truth until they communicate? The implication is staggering. Reality is not objectively definite. It becomes definite through the interplay of conscious observers. Your mind is not a tiny spectator in a vast, pre-existing cosmos. It is a co-author of the cosmic script, collaborating with all other minds to weave the solid world we all share. This places consciousness at the very heart of physics, not as an emergent illusion, but as a fundamental ingredient without which the universe would remain a formless, potential dream. Your own mind is a master strategist in the most complex game ever played, the intricate web of human relationships. The social brain hypothesis proposes a startling answer to why our brains grew so large and powerful. It was not primarily for crafting tools or hunting prey, but for the far more demanding task of navigating our social world. our ancestors lived in ever-expanding groups, and survival depended on cooperation, forming alliances, detecting cheaters, and predicting the behavior of others. This evolutionary pressure forged a brain obsessed with people, a cognitive engine dedicated to social calculus. At the heart of this ability lies what psychologists call theory of mind, the capacity to understand that others have their own beliefs, desires, and intentions which may be different from our own. It is the hidden dimension that allows you to read a friend's subtle disappointment in their eyes, to anticipate a rival's next move, or to feel empathy for a stranger's pain. This social intelligence is not a small module in your brain. It is a pervasive force that shapes vast tracts of your conscious thought. Consider how much of your mental energy is spent replaying conversations, planning what to say next, worrying about your reputation, or simply wondering what others are thinking about you. Even when you are alone, your mind is often a theater populated by other people, a relentless simulation of social scenarios. This is the world of gossip, which from an evolutionary standpoint is not trivial chatter, but a crucial tool for acquiring social information and maintaining the bonds that hold a community together. Your consciousness, then, is not a solitary lighthouse beam shining inward. It is a searchlight constantly scanning the social landscape, a relational mind built to connect, to understand, and to exist within the intricate, invisible fabric of shared awareness. Even when you are doing nothing at all, your brain is humming with intense activity. This discovery upended our understanding of the mind and led to the identification of the default mode network, a sprawling web of interconnected brain regions that lights up precisely when you are not focused on an external task. It is the engine of your internal world, most active when you are daydreaming, reminiscing about the past, planning for the future, or simply reflecting on yourself and your place in the world. This network is the biological seat of your internal narrator, the constant stream of thought that constructs your ongoing autobiography and gives you a powerful, persistent sense of being a stable self. When your mind wanders from this page to a memory of a conversation from yesterday or a worry about a meeting tomorrow, that is your default mode network in its most natural state, weaving the tapestry of your personal identity. Yet this same network, so crucial for our sense of self, holds a darker potential. Neuroscientists have found that its dysfunction is strongly linked to several debilitating conditions. In major depression, the default mode network can become overactive and rigid, trapping a person in a relentless cycle of negative self-referential thought, where every mental loop leads back to feelings of worthlessness or despair. In Alzheimer's disease, the heartbreaking erosion of memory and self is mirrored by the physical disintegration of this very network, as its critical hubs are among the first areas to be attacked by the disease's plaques and tangles. The correlation is so strong that scientists are now studying the DMN as an early warning sign of cognitive decline. This reveals a profound irony. The very brain system that creates your sense of a continuous self can, when it malfunctions, become the instrument of its own dissolution. There is, however, a way to turn down the volume of this internal chatter. For thousands of years, meditation practices have taught the quieting of the mind, and modern brain scans show us exactly what is happening. During deep meditation, the bustling activity of the default mode network significantly decreases. The constant background hum of self-referential thought fades, allowing for moments of pure awareness without a narrator. This quieting is not the destruction of the self, but rather a temporary silencing of the story it tells itself. It suggests that your ego, your most intimate sense of I, is not the totality of your consciousness, but a specific pattern of activity generated by a particular neural circuit. You are not just the voice in your head, you are also the silence that remains when it finally goes quiet. The redness of a rose is a secret known only to you. This deeply personal quality of experience is what philosophers call qualia, the raw fields of consciousness that are private, ineffable, and utterly irreducible to physical facts. It is the sting of a paper cut, the specific bitter taste of dark chocolate, the way a particular melody can evoke a sudden, inexplicable sadness. These are not just data points processed by your brain. They are the very substance of your inner world, and their existence points directly to a hidden dimension of thought that science cannot yet map. To understand why this is such a profound mystery, consider the thought experiment of Mary the super scientist. Mary is a brilliant vision researcher who has lived her entire life in a black and white room. She has never seen color, yet through her monochrome computer screens, she has learned everything there is to know about the physical processes of color vision. She knows the exact wavelength of light that corresponds to red. She understands how the cone cells in the retina fire, and she can describe the precise neural pathways that activate in the brain when someone sees a ripe strawberry. She knows all the physical facts. Then, one day, Mary is released from her room and sees a red apple for the very first time. The question is, does she learn something new? The overwhelming intuition is yes. She learns what it is like to see red. She gains knowledge of the qualia, the subjective experience itself, which was entirely absent from her complete physical description. This reveals a fundamental gap in our understanding of reality. You could have a perfect third-person account of all the physical events in a brain, every last spark and chemical transfer, and still be missing the first-person reality, the what it is like to be that person. Your own consciousness is filled with these ineffable qualities. Try describing the smell of rain on dry earth to someone who has never experienced it. You can talk about petrichor and the release of geosmin molecules, but you cannot transmit the actual sensation. The qualia is the thing itself, the private movie of your mind that no one else can ever fully watch. This is the most direct evidence that there is more to thought than mere computation. The silent, invisible landscape of your feelings, the joy that has no mass and the pain that has no location, suggests that your mind touches a reality beyond the physical, a hidden dimension where the universe experiences itself. The universe seems to know we are here. Its fundamental forces are balanced on a razor's edge, a delicate calibration so precise it feels intentional. If the force of gravity were even slightly stronger, the universe would have collapsed back on itself moments after the Big Bang. If it was slightly weaker, stars and galaxies would never have formed at all. The same goes for the strength of the nuclear forces and the mass of elementary particles. This is the fine-tuning of the cosmos, a series of cosmic constants set to such exact values that even the tiniest deviation would render the universe sterile and lifeless. The anthropic principle is our attempt to grapple with this staggering improbability. In its simplest form, it states a tautology. The universe we observe must be compatible with our existence as conscious observers, because if it were not, we would not be here to notice. But this logical statement quickly spirals into something far deeper. Why is there a universe that permits observers at all? Why does reality have a bias toward life and mind? One provocative interpretation is that this is not a lucky accident. It could be a profound clue that consciousness is not a late-arriving guest in a dead universe, but a fundamental feature written into the cosmic blueprint from the very first moment. The laws of physics may be the way they are precisely because those laws inevitably lead to the emergence of beings who can look back at the cosmos and comprehend it. In this view, the universe and the conscious mind are not separate entities. They are two sides of a single coin, a self-consistent loop where a thinking cosmos gives rise to thinkers who, in turn, complete the universe by recognizing its existence. Your ability to question the stars is not a random fluke. It is the universe fulfilling its own deepest nature, awakening to itself one conscious thought at a time. We have journeyed through an astonishing landscape of ideas, from the holographic projection of reality and phantom Boltzmann brains to the quantum symphonies in our neurons and the possibility of a simulated cosmos. We have explored ancient bicameral minds, planetary consciousness, and the cosmic library of the Akashic Records. Each of these 30 theories, in its own unique way, points toward a single, breathtaking possibility that the hidden dimensions of thought are not separate from the universe but are woven into its deepest fabric. Whether through the lens of quantum mechanics, cosmology, or philosophy, the evidence converges on a profound and mysterious relationship between our inner awareness and the outer cosmos. This journey challenges our most foundational assumption that we are merely biological machines inside a dead mechanical void. Instead, we might be active participants in a reality that is, at its heart, conscious and self-knowing. The greatest frontier is not outer space, but the inner space of our own minds, a universe of thought waiting to be explored. We would love to hear which of these theories reshaped your reality. Share the idea that blew your mind in the comments below. Ask the questions that keep you up at night, and subscribe to continue this journey into the universe's biggest